following flow conditions characterize critical flow. 1. The specific energy is a minimum for a given discharge. 2. Discharge is a maximum for a given specific energy. 3. The specific force is a minimum for a given discharge. 4. Discharge is a maximum for a given specific force. 5. The velocity head is equal to half of the hydraulic depth. 6. The mean velocity is equal to the relative celerity of dynamic waves. 7. The Froude number is equal to 1. The celerity of dynamic waves is the celerity of dynamic waves relative to the flow is positive waves move with the flow. They are primary waves. Negative waves move against the flow. They are secondary waves. Under critical flow, secondary waves remain stationary. Under subcritical flow, secondary waves are able to move upstream. Under supercritical flow, secondary waves can only move downstream. Subcritical flow is controlled from a downstream section, since secondary waves are able to move upstream. Supercritical flow is controlled from an upstream section only, since secondary surface waves are not able to move upstream. Critical depth can occur in two modes. 1. Along the channel in uniform flow, and 2. At a cross-section in either gradually or rapidly varied flow. A channel where critical depth occurs throughout its length is a critical channel. The slope of the critical channel is the critical slope, S sub C. The cross-section where critical flow occurs is a critical cross-section. The friction relation for uniform flow in a hydraulically wide channel is in which S sub O is the bottom slope or bed slope, and F is an open channel friction factor equal to 1/8 of the Darcy-Weisbach friction factor. Under critical flow, the Froude number is equal to 1. Thus, the friction factor equation reduces to in other words, the friction factor and the critical slope are one and the same. For applications to gradually varied flow, it is convenient to recast the friction relation as in natural channels, critical flow appears to be a self-regulating upper limit to the Froude number. This is because as friction increases due to bed form roughness, the Froude number cannot continue to increase and still satisfy the friction equation. In artificial channels with no bed form roughness, supercritical flow is possible. Under critical flow, the Froude number is equal to 1. For computational convenience, we square the Froude number. From continuity, V is equal to Q over A, and hydraulic depth D is equal to A over T. This equation can be expressed as in a typical prismatic channel, the input hydraulic variables for critical flow are 1. Discharge Q, 2. Bottom width B, and 3. Side slope Z, Z horizontal to 1 vertical. For B different than 0 and Z different than 0, the channel is trapezoidal. For Z equal to 0, the channel is rectangular. For B equal to 0, the channel is triangular. The top width is the flow area is substituting into the critical flow equation, given the input variables Q, B, and Z, this equation is solved for the critical flow depth by iteration.